Today we're talking about scientific notation. Now I have two examples here that are circled. We have this one and this one. These are both written in scientific notation. So before we even talk about what scientific notation is, let's just look at what these mean. We have 2.5 times 10 to the second power, which we could rewrite as 2.5 times 100, because 100 is the same thing as 10 to the second power, which if we wrote it in standard form would just be 250. Now in this one we have 2.5 times 10 to the negative 2, which you guys learned before that 10 to the negative 2 would be the same thing as 1 over 100. So we have 2.5 times 1/100th, which would give us 0.025. Now I want to point out a couple little things that you might notice. If you look up here, 10 has a coefficient of 2. Our decimal is right there. So our decimal is between the 2 and the 5. If you look at our final answer, we moved it once, moved it twice. That times 10 to the 2, we ended up just moving that decimal to the right twice to get our final answer of 250. Let's compare that with this one. We had 2.5 times 10 to the negative 2. And so we have a negative 2 this time. Look at this. We started with a decimal between the 2 and the 5 again. This time we moved it this way once and twice to get an answer of 0.025. Let's make that decimal a little bit more clear for you guys to see. So if you notice, all we have to do to write these, to take scientific from standard, is we just have to move the decimal however many places we have in the 10 spot. In this case, we have 2, we move it to the right twice. It's going to be a bigger number, right? Positive is going to make it a bigger number. To the negative 2, this 2.5, we're writing a smaller number, a much smaller number. So you guys can kind of see how the scientific notation works, but what is it? How do we use it? Well, it's something that we use in science to represent really large or really small numbers, like the size of the sun. You're going to use scientific notation to represent it because who wants to write a whole bunch of zeros? You know, if the sun was 482 million billion centimeters wide, you don't want to write all of those zeros out. So instead of doing that, you can write 10 to a certain power times the coefficient. Now, an important thing to note with scientific notation is when it's in proper scientific notation, you will only have one number left of the decimal. So let's look at, if I have 12.4 times 10 to the 4th and 1.24 times 10 to the 5th. One of these is not in proper scientific notation. You know which one it is? It's going to be the first one because we have two numbers to the left of the decimal. We should only have one whole number left of the decimal, so we wanted to move that over. Okay, your answer, you should be looking at 1.24, not 12. Always, always, always only have one number left of that decimal if you're supposed to put it in scientific notation. There, I'll move that up, be able to see a little better. Always only one number left of that decimal. Okay? 1.24 times 10 to the 5th. This is one in scientific notation. 12.4 times 10 to the 4th is not. We'd have to move that decimal and change our coefficient. So let's look at a couple examples where this might be useful. Number 1, we have a nice big number, 6,714,000,000, whatever, dollars, pounds, whatever we want to say. This number's getting kind of big. Can we write it as scientific notation? And the answer is yes. Now, setting this up, we know that we have a decimal right here, and we need to move it. How many, so let's put a decimal here. How many numbers do we have left of the decimal? Only one. It's going to have to go between the 6 and the 7. So we have a 6, decimal's going to go here, 0.714. The rest of these zeros, we don't need to hold on to those. We can always, there's always zeros there. You have 20 and then a decimal. There's unlimited zeros after that decimal. We just know it's exact. Now putting this in scientific notation, we're going to take it times 10 to a certain power. How are we going to figure out that power? Well, we can count how far we need to move the decimal. So you can count these one at a time, but when you have a comma, you can always say, well, we have 1, 2, 3, or you could say I did 3. There's 3 there. 6, 9. We moved it 9 places. If you count it out, you would find 9 places. So we're going to take 6.714 times 10 to the 9th power. It's that easy. You just have to count how many places you had to move the decimal. And remember, the decimal goes so that you only have one number left of it. Now looking at number 2, we have a number in scientific notation. Let's write this one in standard form. So we see that it has a negative coefficient. It's going to be a small number. Let's start out with our initial 525. Now to write this one, let's work backwards. We need to move this decimal place 4. Because it's negative, it's going to be going the opposite direction. So we moved it once. Okay, that's 1, 2, 3. 1, 2, 3, 4. Decimal goes here. Our answer is 0.000525. That's just really all there is to setting up scientific notation, whether you're taking a number in scientific notation and writing it in standard form, or taking a number in standard form and putting it in scientific notation. You're just moving the decimals, using a power of 10 to represent that, having one coefficient to the left of the decimal. That's it.